Hello, 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 everybody. Welcome back, welcome back. We're here with another math contest, the 2002 Cayley competition, and we've just been plugging away at it. Hopefully you've tried it as well. We're on question number 15. That's the one we're going to take a look at today. In the grid shown, it is only possible to travel along an edge in the direction indicated by the arrow. So we got tons of arrows over here. The number of different paths from A to F is, okay. So with a question like this, there's sort of a general technique that I use if the diagram is small enough. If the diagram's pretty big, you have to start thinking a little more cleverly. But with this diagram, this tiny one here, I think it's going to be best just to reach, just to count the number of ways we can do different things. So for example, I can count the number of ways I can get from A to D. And I can count the number of ways I can get from A to B. And then if I count the number of ways I can get from B to E, I can add those up, and that'll tell me how many ways I can get from A to E by going through B, things like that. Now, that might have sounded complicated, but that's because I'm explaining it verbally. It's much better. Let's just jump straight to the picture. We'll draw the picture out, and I'll show you exactly how this works. It couldn't be simpler, in my opinion. So, we'll draw ourselves a picture. The nice thing is, if we take a look at this, there are sort of no loops. Otherwise, the answer would be infinity. So I think there's another one down here like this. We got this guy here, this here, this here. So we have A, we got B, C up here, D down here, E, F, and let's just go back, make sure we copied the whole thing properly. Yep, we're all set. So, I usually mark the edges as I go through them, or mark the letters as I reach them. So how many ways can we go from A to D? Well, once we go over to B or E, we're stuck. We can't go back. So there's really just going down this one arrow. One way to get to D. Similarly, there's only one way to get to B. A to B. That arrow is the only way we can do that. Now, there's one way we can get to from A to E directly. So there's one way to reach A. Now, if I wanted to, and that's just starting at A. If I want to figure out how many ways I can reach E, well, how many ways could I reach D? 1. And then go to E. How many ways could I reach E just from A? You add up all the nodes that sort of lead into E. So 1 plus 1 plus 1, 3 ways I can reach E. How many ways can I reach C? Well, only one node has an arrow leading into C, and that's B. There was one way to get to B, and then from B to C, there's only one path, so there's still one way to get to C. That's A to B to C. That's the only way you're ever going to get to C. Now, if I want F, well, how many things lead into F? There's an arrow from B, an arrow from E, and an arrow from C. So I just add them up. 3 plus 1 plus 1 is 5. And incidentally, this is 1 plus 1 plus 1. If there were a larger grid, you start from the beginning. There's one way to reach the beginning, and you just branch out. You label all your nodes. You count up all the different ways, and it's actually quite effective. And so now we know there are 5 ways to reach F. Okay? If we wanted to, we probably could write them all out. But there's not really any need to. I think, yeah, I'll waste some time and do that. So we can go A to B to F. That's probably the most direct way. A to B to C to F. And then there are all these ways we can go through E. This also tells you, how you can make the paths. There should be only one coming from C. There should be only one that just ends BF. That sort of thing. So we go E to F. That'll be the end. And then how many ways could we get to E? Well, we can go through D. So we can go A, D, E, F. We could go through B, so that'd be A, B, E, F. Or we could just go straight there, A to E, and then on to F. So these are our 5 possibilities. You could have probably just done a little guess and check and maybe exhausted yourself and said, well, I can't think of any more, so it should be 5. But there we have it. 5 better be one of the answers, and there it is. It's B right there. That's the final answer of B. And that does it for question number 15 on the 2002 Cayley. I enjoy this technique. The grid was kind of small, so you didn't get to see it in full effect and exactly all the different cases and ways it works. But it's a really nice way of counting if you are forced to go along certain paths. These sorts of questions pop up every couple of years. So it's nice to have this way of counting paths under your belt. And you label the node with how many ways I can reach it, and then you start adding things up. Really nice. Really simple in my opinion. So anyway, question number 15 done. We're looking forward, looking to the future. That's question number 16, and we're going to take a look at that in the next video. So thanks for watching.